Hello everyone and welcome to our presentation. Today our team will be sharing how we built our own personal cloud storage system, a secure, low-cost alternative to commercial cloud services using a Raspberry Pi 4, Rockstor NAS, TAILscale VPN. With this setup we created our own personal cloud, like Google Drive, but faster, private, and subscription-free. I'd like to introduce our team. My name is Salame. My partners are Sherman, Liang, Contreras, Hanson, Liew, and Andrew Morales. This is our presentation agenda, which services used. We use DistroWatch, a website where you could find and download ISO files for specialist Linux operating systems for building. We used a Raspberry Pi 4 with Rockstor NAS and TAILscale VPN for secure remote access.
Let's go ahead and start talking about Rockstor NAS. What exactly is Rockstor NAS and what is a private cloud? Rockstor is essentially a free open source Linux-based network attached storage, which lets you turn on any computer into a centralized storage server. It's mainly designed for file sharing, backups, and hosting media or other data over a network, and it can be run on most widely available hardware devices like Raspberry Pi, ARM, or x86 architectures, and uses a web or browser-based graphical user interface, and also managing storage, users, shares, and apps. It uses file sharing protocols like SMB, CIFS, NFS, and SFTP so that clients across all mainstream operating systems can access the stored data. Using Rockstor, you can build your own private cloud storage. It can be integrated with public storage for greater efficiency and lower cost. With Rockstor, it is possible to customize your cloud to your preferences and also manage storage with your own IT experience. Rockstor NAS uses many networking protocols. SMB and CIFS are protocols that support file sharing with Windows, Mac OS, and Linux clients. They allow applications or users to read, write, and manage files on remote servers as if they were local. Rockstor uses Samba to export shared folders called shares to the network. Network file system is a Unix and Linux native network file system that allows remote directory mounting. Secure File Transfer Protocol runs over Secure Shell and provides secure, authenticated, encrypted file access using SSH's built-in security. Rockstor's SFTP service is handled by OpenSSH, managing user accounts and permissions. Apple Filing Protocol is Apple's legacy file sharing protocol. Docker Network Bridges, or RockNets, provide network segmentation for rock-ons, which keeps activity between apps and external networks under control.
We decided to integrate TAILscale as a secure VPN and mesh networking solution because it makes remote access simple and safe without opening public ports or setting up complex gates. Rockstor includes TAILscale as a manageable system service, so we can enable and configure it right from the web interface with peer-to-peer encrypted tunnels powered by WireGuard, zero trust access, and support for multi-cloud edge devices. TAILscale gives us seamless connectivity between our systems anywhere. Okay, so this is all well and good, but how does this actually work? So instead of routing traffic through a central server, it creates direct peer-to-peer encrypted connections between devices. The TAILscale control plane simply coordinates which devices can talk, but your data always flows point to point. Behind the scenes, it uses NAT traversal and hole punching to connect through firewalls automatically. And when that's not possible, it falls back to DERP relay servers to keep connections reliable. Control plane handles key distribution, peer discovery, and access control, while features like IP forwarding, subnet routing make your private network behave just like a seamless secure LAN across cloud, edge, and on-prem devices.
So a Raspberry Pi 4 is what's known as a single-board computer, which is a complete computer on a single circuit board with key components of a computer, as shown in the diagram, and this includes microprocessors, memory, and input-output. The Pi 4 model specifically runs a full Linux-based operating system and Broadcom ARM-based system-on-chip quad-core Cortex-A72 CPU and video-core VI GPU. It has built-in Wi-Fi and Bluetooth and is capable of playing 4K video at 60 frames per second. It's a low power and energy efficient with roughly 3 watts of power draw, which costs about 0.05 cents per hour, which makes it ideal for always-on applications such as network-attached storages or Internet of Things devices. It's a cheap product with the introductory price point for the smallest model being roughly $35. So if you're curious what real-world application a NAS could have, look no further than the October 20th, 2025 AWS outage, where DynamoDB, which is a centralized database service used to track user information, store key data, and manage Amazon operations, became unavailable. Amazon attributed this outage to domain name system issue, where the system was unable to locate the database, which caused many services to become unavailable, such as Snapchat, Roblox, Signal, and Canvas. And a self-hosted NAS would have been able to avoid these service outages by 1. Supporting private cloud deployment, where the private NAS would host resources from the organization's own data center. 2. Supporting application deployment, where developers' web-based and server-side web applications would be supported by the NAS. And 3. Providing data redundancy, where important data is backed up locally, even if deployments use third-party clouds such as DynamoDB.
Network diagram. In this slide we show how we built our own personal cloud storage system On the left, you can see Andrew's home network running a Raspberry Pi 4, which provides file sharing, in this case a 1 terabyte drive. The Pi connects through his home network via router, so that's going to be accessible to all team members. TAIlscale VPN, which punches a hole through the NAT on his router. TAIlscale builds a secure encrypted mesh network using WireGuard protocol. Each team member's device, whether it's a Windows, Mac OS X, or Linux, runs TAIlscale client that securely connects it to the Raspberry Pi 4. TAIlscale coordination server, shown in the cloud diagram at the top, handles authentication, key exchange, and network discovery, but it never sees or decrypts your data. This gives us end-to-end encryption, zero trust security, and NAT traversal, meaning no router port forwarding or configuration is needed. On the right side, each team member, once logged in, they appear to be on the same local network as the Raspberry Pi, allowing for secure file access. We get cloud convenience, data ownership, and low-cost scalability, all powered by open source software. So you want to build an open source network attached storage device. You got to come to this website called distrowatch.com. Do a search for it over here in the box, and then I get Open Media Vault Rockstor. It gives you a link to their download page. When you click on that, it takes you out of the DistroWatch website. Now you're at you can see here that, hey, look, this is based on OpenSUSE Leap 15.6. The reason why we went with the Raspberry Pi 4 is because the power consumption. It consumes less than 5 watts of power. Download the ISO, this raw exe file, and the next step, I will show you how to install it with the Raspberry Pi application. It's a free open source NAS that runs on Raspberry Pi. This is going to be a Raspberry Pi 400. We're going to put it on this little 64 gigabyte device I'm picking is a 400, and we're going to choose an operating system, use a custom image. This is a Raspberry Pi 400. They basically are a keyboard with a Raspberry Pi 400 inside with all the ports on the outside, and this little micro SD card in here. Up here in a second, just automatically starts, right? And it's installing all the components that need to be installed, create an app. It's now asking me to log in, so that'd be root, my IP. Okay, so it pulled a 206 IP address. It asked me to do an update on the OpenSUSE, so I guess it's downloading all the updates. Hopefully everything is running. Let me try again. Hopefully it'll work with HTTPS. I guess it's telling me that is what I'm supposed to use. Looking over here, telling me that I'm supposed to use HTTPS to see if it'll let me log in. Let's give it a crack and see if it works. It worked. So yeah, super happy. So this is what the dashboard looks like. Yeah, all right, so yeah, this is pretty cool. It's running on the network here, which is pretty awesome. And now my partner Andrew Huerta will demo Rockstor NAS from his home on his Raspberry Pi.
Hello and good afternoon everyone. This is Andrew Huerta Morales recording this video from home, and welcome to Rockstor. In this video, I'll be giving you an overview of the Rockstor web interface and walking you through how I turned my Raspberry Pi into a fully functional network attached storage system. I'll be demonstrating how to set up a shared folder using an external drive connected to my Raspberry Pi, how to export that share over my local area network using Samba, or otherwise known as the SMB file sharing protocol, so that way it can be accessed from any other computer within my network, how to create user accounts and assign them to groups and manage permissions, and finally showing you how I configured remote access so my project partners can connect my NAS securely outside the network using a TAILscale VPN. First, let's go over the dashboard. Currently, I'm on the main dashboard of the Rockstor web UI. In this dashboard, you are able to view multiple tiles that give you live information about your Raspberry Pi. This includes pool capacity, disk activity, CPU, and memory usage. Let's first go over what kind of external memory we have available on this NAS. In this page, you have an overview of the different external drives that are available for storage. The first one that is listed is the main Raspberry Pi. An SD card worth up to 125 gigabytes was used for this image, but the two below are available drives that I am able to use. Currently, I have a 250 gigabyte external hard drive and a 1 terabyte external SSD connected to Raspberry Pi via USB. Rockstor makes it very simple to use these drives, as you simply just connect them and format them within the web UI. Let me show you how to make a share. As you can see, I already had set up 2 share folders while testing Rockstor, and I've only allocated half my SSD drive's memory to the folder titled Share Drive. I'm going to be creating another share folder for this demonstration. This page is pretty self-explanatory. You can name your shared folder whatever you like, pick which pool you'd like to use the memory from, and manually use the slider or enter a specific amount of memory you'd like to use. The pool name that I had set for my SSD is titled Team Share. I'm going to set 200 gigabytes for this example. And just like that, I now have a separate shared folder titled Demo with 200 gigabytes worth of memory space that I can use. I need to configure this folder so that anyone who has access to this folder can edit documents. Here in the Access Control tab, you can see the types of permissions everyone has when they connect to the demo folder. Here it shows that only the owner is able to read, write, and execute anything within this folder, while any specific group or anyone else for that matter is only able to read and execute. I want my group to be able to access this folder and be able to read and edit whatever is on this drive. I will also be changing the group from root to user so that Any account that I make under the user group will have the same privileges. Now that I have created my shared folder and configured its privileges, now it's time to finally put this on the network. On the left side of the screen, Rockstor makes it easy to do this process. As you can see, it is categorized in steps, and the final step is file sharing. Here, I already have exported the shared folder known as shared drive, but now we are going to export the demo folder. In this page, Rockstor will be asking which share you would like to export. I'll choose demo, select my main Rockstor account as the admin user, and we will keep this folder browsable, but not allow any random guests to make changes and not make this folder primarily read-only. Once that's done, we should be able to see the folder once we map a network drive to the IP that Rockstor assigned to me when I first installed the OS. I will now open my File Explorer, scroll down and right-click on the Network tab, and select the option to map a network drive. You could label this drive whatever you'd like, and all you need to enter is Rockstor's local IP address to access the exported shares. Hit the Browse button and click on the down arrow to show the different shared folders that are connected to that IP. I will then be prompted to enter my Rockstor's credentials. For this, I'm going to be using my admin credentials, entering my username and password. Now I can finally see my demo shared folder. Once I click on that and select finish, I will have successfully mapped a network drive to that shared folder. Now I have a local NAS available to me as long as I'm connected within my network. There is still the issue of my group members gaining access to this folder. The only possible way right now would be for each of them to come into my home, connect to my Wi-Fi, and then gain access, and that's just not convenient for everybody. And there is also the issue of maintaining a secure connection to prevent any malicious actors from accessing this network share. Why don't I set up a VPN on my Raspberry Pi so that way I can create an encrypted tunnel that my group and I can access even when they are outside of my network? After a bit of research and a few recommendations, I discovered TAILscale. TAILscale is a free VPN that anyone can download and install on any of their devices. Setting this up was surprisingly easy, as Rockstor has TAILscale as a compatible service that you can enable within the service page that is located right underneath the service tab. Once that is enabled and my TAILscale account has been set up, I'm going to need to download and register TAILscale onto my Raspberry Pi first. I will click on the service tab and head down to the bottom and click on System Shell. And since I already have installed and registered my device, I will be putting up these commands specifically for the OpenSUSE OS that Rockstor is built off on for setting up TAILscale. Once these commands have been entered, the terminal will provide me a website link that I could copy and paste into my browser that will take me to TAILscale to authenticate and connect the Pi to my TAILscale network. Once that is done, I will input the myIP command into the terminal and you will see a newly assigned IP address appear. And if I have any other devices registered on my TAILscale VPN, then I can access my Pi anywhere outside my home network, and this same idea applies to my team members as well. Now I will log into my TAILscale account and give you all a quick preview of my main dashboard. This is what's known as my main tailnet. I already have a few lists of devices that I have connected, but the one that I really want to focus on is the NAS Pi. When I click on share, you'll see my team members Angel, Edward, Hanson, and Sherman, who have all downloaded and installed TAILscale on their own devices, have already been accepted specifically into my Raspberry Pi's network. All they need to do is have their own TAILscale VPN up and running on their own devices, and then when mapping to the network drive, they'll be using this IP address to securely connect to my share folder. The last thing that there is left to do is create a Rockstor user account for my group members and assign them to the users group. This would be located right under system, and we'll click on user. And because I already had created all the users beforehand, I'll just give you a quick example of how I went about it. I will click on add user and enter a username and create a simple password for them. And finally, I'm just going to make sure that they're assigned to the users group. And that's it. Thank you for checking out my demo. Now I'm going to pass it over to Edward.
And here is a list of commands of Linux Ubuntu client to install TAILscale. You have to install a few commands with curl, then you have to do an update, then you do a apt-get install TAILscale, a sudo TAILscale up to turn it on, and a TAILscale IP -4 to get the IP address, the VPN. Once you have your TAILscale client installed on your Linux installation, we have to activate it. We're going to run the command TAILscale up, which will turn on the VPN. It's going to ask you for the password, and then we're going to run another command to see what the IP address is going to be. Once you have that set up, you open up any file explorer, you connect to server, you put in the IP address that you're going to find that Andrew had provided for us previously, and you paste that into the connect to server dialog box through the username and password that Andrew created. Then you click on the connect button and you're going to see that it's actually connecting to that, and the shared drive is, so I've punched a hole through my local area connection, went out to the internet, connected to TAILscale's point-to-point, and I'm actually logged into Andrew's attached storage in Andrew's house. So what I'm going to do right now is I'm actually going to copy the final demo that we just saw Andrew, the video, for me to copy down to my local machine so I could add it to our final PowerPoint presentation. So as you can see right now, I'm copying a 100 megabyte final demo video video that Andrew created on his home computer, copying to my machine through the internet at 2 megabytes per second. So that's the kind of performance that we're going to be able to see out of a Raspberry Pi 4 being used as a NAS. We have our own cloud storage for $60. So pretty cool. To be able to see what the TAILscale admin control panel looks like, you're going to get this URL in the command line after you're done installing the TAILscale. You're going to get prompted to log in, and it's going to ask me to authorize it. And you're logged into the admin panel. Andrew's NAS at his house connected right now. It's showing that .44 IP address. Also that I'm connected here on my little Surface Pro running Linux Mint. And there you have it, guys. That's the TAILscale control panel, and that's how you manage your VPNs remote. Thank you so much, guys. I really appreciate your time.
So what did we learn from this presentation? As we have shown, NAS are valuable systems that can support any business with multiple features. First, NAS require less dedicated hardware than traditional servers. This in turn allows a NAS to consume less power, which results in lower costs overall. Second, we saw that the web-based dashboards make installation relatively simpler compared to command line only server racks. Adding and removing hardware connected to the NAS is simple as well. Third, multiple hosts can remotely access the NAS at the same time regardless of physical distance. These hosts can also vary in their own architecture since file sharing protocols can intelligently translate between the systems. And from there, your options for what you want to do with a NAS is vast. Media streaming, data backups, virtual machines, lightweight application hosting, NAS are perfectly capable of all of them. And lastly, NAS networks are private with greater local data control, user access control, and encryption than a cloud provider's network.